Well, hey there, kiddos. Today we are going to talk about solutions to linear equations. We're just going to try to figure out if something actually is a solution to what's called a linear equation. We're going to have equations that have two variables, a y and an x, so we can't just solve like you're used to solving an equation. But we still want to know if a point that we're looking at is a solution, if it's an answer. So the first thing I want you to do, I'm going to have you pause the video for just a minute, and I want you to plot these 5 points, and then I want you to answer the question underneath the table. Well, alrighty, so you can see we've plotted our 5 points. There they are. I've even labeled them for you. And the ones that lie on the graph that we graphed, the ones that are actually on the line are A, D, and E. I put them in order, but alphabetical order, but you can, as long as you have those 3 points written down. Those 3 points are going to be considered solutions to my equation. Okay, well, a solution to a linear equation is just any ordered pair. It has to be an ordered pair. It has to have an x and a y value that makes the linear equation true when substituted in. So if I happen to know what my equation was for that graph that's on the graph of number 1, I would be able to tell that point A, point D, and point E, if I plugged them in, oh, I do know the equation. If I were to plug these points into this equation, it would make them true because they lie on the line. So like, for example, point A is 0, 1. So if I took my equation, y equals 2x plus 1, and I plugged in my x and my y value, well, y is 1, and x is 0, and when I plug that in and find out what it equals, 2 times 0 is 0, plus 1 is 1, so I get that 1 equals 1. So it makes the equation true, which is why the point lies on the line. So a solution is just an ordered pair that makes the equation true. So for number 2, using that equation, y equals 2x plus 1, we're going to complete this table right here. And we're going to answer some questions about it. So we're going to complete the table. This process column is fairly important, so you want to make sure that you are filling it in as you go because it shows you what you did. And there's no way to know how to know what to do if you don't know what you did to start with. So if x is negative 2, I'm going to plug that in. So I get y equals 2 times negative 2 plus 1. Well, 2 times negative 2 is negative 4, plus 1 is going to be negative 3, so y equals negative 3. So my ordered pair is going to be negative 2, negative 3. This is going to be a solution to this equation, because if I plug these back in, it's going to make that a true statement. Because once I plugged in x, I got this back out as an output. When I put this into the input, this became the output, makes that a true statement. So the next one, and that I believe is supposed to be a negative sign. When I shrunk the table, it squished it up. So that's negative 1.5. So you have y equals 2 times negative 1.5 plus 1. Well, 2 times negative 1.5 is going to be negative 3, and negative 3 plus 1 is negative 2. So here is another solution, negative 1.5, negative 2. So I'm going to have you pause one more time. I want you to finish filling in the table, and then we'll go answer questions 3 and 4. So all of these values that you just got in this table, double check them, make sure you got yours correct. If you didn't, fix your arithmetic mistake. But here, all these points right here are solutions to this equation, 2x plus 1. Are they the only solutions to this equation? Absolutely not. There's no way they're the only solutions because there are more numbers that exist other than these. I can plug in any number I want for x, and whatever my y output is will still be that will still make an ordered pair that's a solution. Okay, so why not? Because I can plug in more numbers. We could come up with several more solutions to this, but all of these definitely are. So number 4 asks if 6.5 and 14 is a solution. Well, we're going to check. We're going to plug it in. Y is 14. X is going to be 6.5. And so we're just going to do the math. Well, 2 times 6.5 is 13, and 13 plus 1, last time I checked, was 14. So I get 14 equals 14. So yes, it is a solution because it makes this true. The justify your answer part is all that work we just did. So to summarize, a solution of a linear equation They left out the word there. I think it should say linear because it's not just an equation. A solution of a linear equation is an ordered pair that falls on the graph of the line. And it is a set of x and y values that when you substitute into the equation, they make a true statement. So both of those things have to happen, but if one happens, the other will happen, so they go hand in hand. So that is the solution to a linear equation. So let's practice a few more. Number 5 asks if negative 2, 1 is a solution to this equation and to justify your answer. Well, justify means show your work. So we're going to substitute this in. X is negative 2, y is 1. We need to test it to see. Well, 3 times negative 2 is negative 6. Negative 6 plus 1 does indeed equal negative 5. So yes, it's true. It works. There's my justification. Now, number 6 asks which one is not a solution. So we want the one that doesn't work. So I'm going to have to test them all. But I'm going to plug in each one of these points until I find the one that doesn't work. So I'm going to give you a second, pause again, go check them, and then come back and we'll see which one's the right answer. So I've gone and plugged in each of my values into my equation, and I have worked them all out. And please be careful when you do these that have the minus sign and then they are subtracting a negative. You want to do minus a negative. Don't just write the minus once. And so like for this first one, A, when I plugged that in, 2 times 3 was 6, but it was minus a negative 6. And remember, if you do your rules, leave, change, change, that becomes 6 plus 6, so it does equal 12. You have to be very careful with your negatives. Hopefully you kept up with those as you went, and if you did, as you plugged them in, you should see that C right here, once you plug in your numbers, equals 10, not 12, and so C is the one that's not a solution. All the others work out. Now, number 7 gives you an equation and it asks you to solve it giving the domain. Well, if you'll remember, domain is the x value, so they've given you x, they want you to find y. So we're going to plug in and we get to do it 3 times. So we're going to do it once and I'll have you practice the other 3. So I have 4y equals 4 times negative 3 minus 12. And then we're going to solve it. So 4y equals, well, 4 times negative 3 is negative 12. And negative 12 minus 12 does not equal 0. It equals negative 24. And so then I have to solve this for y, so I divide both sides by 4. So when I do that, I get one of my answers is y equals negative 6. So that's what this equals when I solve this one, because negative 24 divided by 4 is negative 6. So now I'm going to have you pause again, try it with the other 2, and come back and check your answers. So as you can see, I've plugged in my numbers, 1/2 and 1 in for my x, and I have solved for y. And so my values that I got when I plugged in for the domain is negative 6, negative 5/2, and negative 2. Those are my 3 answers. And so if this is the domain, then these 3 values make my range, and I can write them as a set like we did for the domain if you want. So part B says for the same equation, what is the value of y if 5 comma y is a solution? Well, they're telling you right here that x is 5. So you take the same equation, 4y equals 4 times 5 minus 12, and you just solve for y like we did before. Well, 4 times 5 is 20. 20 minus 12 happens to equal 8. And when I divide both sides by 4, you get that y equals 2. So the value of y is going to be 2. So in order for this to be a solution, it has to be the point 5 comma 2. Now number 8 is a very similar question. It says solve the equation 5y equals 10x minus 5 if you are given the range. This time they give you the y values. So we're going to treat this like we did number 7. I'm going to do the first one with you, then I'm going to have you pause, try the other 2, and then come back and check. So now I know that y is these values, so I have 5 times negative 3 equals 10x minus 5, and I'm going to have to find x. Well, that makes negative 15, and so I have to solve this. I'm going to add 5 to both sides, and when I do, I get negative 10 equals 10x, and when I divide both sides by 10, I get that x is negative 1. So one of my values for x is going to be negative 1. So pause, do the 5 and the 7, plug them in, and then come back and check your answers. Okay, so as you can see, I've plugged in my 5 and my 7, and I have worked out and solved the equations, and so I got x equals 3 and x equals 4. So here are the 3 values that I get for x when I plug in these values for y, which means that if these are the range, all these 3 numbers make up my domain. And so that's how that works. That's solutions to linear equations. We will practice this when you come to class tomorrow. I will see you then.